I'm Shadab Ahmed. I'll be speaking on Inside Git Guts with Ruby. Can you see the text? Let me increase it. More? It's okay. Left is fine. So let me start with your big warm welcome. Okay, it's asking me to reduce the size because it's really big. So let me just reduce the size even more. So there you have it. Now it's a big welcome, as I said. Let me clear it. Let me change the font size back. And let me explain a bit about myself. Okay. So it didn't come out right, but you can get most of it. And the last claim is maybe a bit of exaggeration, but you won't test it anyway. So cool. So before we move further, how many of you guys use Git? Okay, lots of people. So I'm speaking to the right audience. And do you know what Git means? Anybody? Yes?
There are two names. One is Global Information Tracker, and it also means a guy who is.
And so Git is a slang for an idiot. In fact, that's what the name was intended to be. But why would a guy who creates a software and names it Git? Why would he do that? Why would he name it stupid? So let me show you a quote from the creator himself. And that's why he named it Git. So let's move further. Let's actually start something. So let me clear it. And let's start a Git repo. Let's create a Git repo. Git init, that's how you do it. Git my repo. And you see that an empty repo is initialized. And let me go into my repo. There's nothing. Nothing except a .git folder. Let's go inside this .git folder. Let's see what it contains. Okay, it contains a lot of files, but one which makes obvious sense is the head. Now let's try to type it. What's inside it? Okay, it contains a reference. So if you can't see, it's ref in the beginning. So it contains a reference to this file. So let me try to type this file. Okay, it says no such file or directory. Why would it say that? Because there's no commit yet. So let's go back and try to commit and come back. Let me commit something. In fact, I'll commit in a single line. I also added timestamp in my command, so updated at the timestamps just to differentiate between different commits. And let's just go back into the Git folder and see what happened. Cat head. And let's cat refs heads master. So we have some value actually. And looks like this value is exactly like Git gave us during the commit. So what is this value? How is it calculated? What happened there? So let's try to find this value, where it came from. So let me do this star. Okay, there we see the value. In fact, the first one is a value. Now this, the first object is exactly the same one as that reference. So it's a hash, and the first two letters are a directory. The rest is a file inside that directory. So how did this hash came from? We understand that that hash we got from Git was a file, but how did the hash come from? So let's go back actually and see this hash. In fact, there's a command, git cat file -t, and I can refer to this as head also. Let's see what it says. It says it's a type of commit. You can't see the screen, so let me make it a bit smaller, and let me turn it a bit right. Okay, it's better. So it's a type of a commit. So what does it contain? And we still don't get where the hash came from. So let's try to open this object. Now this is my commit object, and it contains this. So originally the files are stored in a compressed format, so you cannot open it directly. But you can open it with this command which I created. You can also use git cat file, but I find my command more convenient. And this is what it contains. In fact, if you see this tree, this is also an object, and you can see just above that this hash is also exists in the objects folder. So let's try to calculate this hash. How is it calculated? So let me open IRB require digest / sha1, and let me put some content. And this is headoc format. So let me copy this exact text. So we have the content in a string. Let's also calculate a header. So it's a type of commit object and content dot size, and we have a /0 padding. So that's how Git header is calculated. Why is it used? Well, I'll tell you just now. So I got a header, I got a content. So let me try to get the hex digest, and header plus content, and there I have it. And if you see, this is exactly same as the one earlier. So that's how git hash is calculated. So your commit object contains and the header. So any object, in fact, git stores. There's a general typical git formula to create the hashes. So it's header, content, and you get the hash, sha1 hash. So that's how it was calculated. So let me go back. So that's the 4 lines of Ruby code you saw, and that's it, with the Ruby code at least. So let me open that object again. This is my commit object. Let's try to open this tree object. I'm hoping it contains a directory structure. So let's see. It actually contains a directory structure. So first is the file permission. The second one is the type of object. Third one is the hash itself. In fact, this hash also exists somewhere. In fact, one of these is that hash, the file hash. And let's open this file also. And we have A here, and that's the content of our file alpha.txt. So that's how the Git objects are stored. But we are not going to repeat this charade of doing Git open. So let me show you a cool tool. So I just started a Sinatra server, and let me open Safari. Not this one. Not this one also. Okay, I have this commit, and it opens the object for me. And this is an app which shows me an object and all the commits. So I have this tree and I have this blob. So let me do another commit actually. Let me do another commit. I have it. Let's go back. There we have 2 commits. So first one is the original one, and the second one is this. So why did this commit hash change? You see that commit also stores the timestamp. So if I had committed the exact same commit, but at a different time, even 1 second later, it would have given me a different hash. So that's why the hash is different. There's one more reason: the tree hash is different. Why is tree hash different? So let's see why the tree hash is different. Tree hash is different because the content is again different. This hash changed. Rest everything was same. I'll show you. This hash changed. Everything else is same. So our hash changed, and obviously our content changed. In fact, I can see the diff also. What changed here? Okay. So what if the content didn't change? What if I did not change the content at all? What if I just moved the file? So let me move the alpha.txt to alphabet.txt, and let's see what happens. Now my commit obviously changed because it's a different timestamp. My tree also changed. Why did tree change? Let's see. Because the file name changed here. If I see here, my tree had a different file name. But observe this hash. This is exactly the same hash as this one. It's the same hash. So Git actually reused the object. That's how, if you don't change any file, the file from old commits is used. In fact, let's go inside the Git folder. Let me see cat ref heads master. It shows me the latest commit, obviously, and it shows me lots of objects. In fact, let me get the count. We have 8 objects actually. So we had 3 objects from this, the commit, the tree, and the file, and we have 3 commits. So we should have 9 objects. But why do we have 8? Because we repeated one object, we reused one object. Okay, so what if we create a folder? So how will that happen? How will Git store that? So let me make a folder. Let me commit something there inside the folder. Okay, sorry, I'm in the wrong place. Okay, mkdir folder, and let me commit again. So now I have the commit, and let's see. We have 4 commits right now. And what's inside this commit? Let's see. There's a tree. The tree has changed because the content changed. And you can see there's another tree inside that. And then you have the blob. And going back, you see again we reused this hash for alphabet.txt because the file didn't change at all. So, but we won't keep going inside the Git folder. Let's just see finally. We have 12 objects right now. Why so? Previously we had 8, but we have 12 objects right now because we have a new commit object, a new tree object, a new file object, and the other file. So we have 4 objects additional. So that's why we have 12 objects right now here. But it doesn't seem right that we keep using this, going into the Git folder, then exploring it. Doesn't make sense. So what, we need a better way to track these changes. So what could be? So before we go further, can I have the music please? The computer music? Yes, a little louder. Let me stop. Okay. So can anybody identify that music? Inception. It looks like there are a lot of fans of that movie. Even I'm a big fan. I've seen it like 4 or 5 times. And my brother in the crowd has seen it at least 10 times. 5 times in the movie hall. Dude, where are you? Just stand up and show yourself. Okay. But why are we playing this music? What's the relationship with Git here? With Inception. So for those who haven't seen this is a movie about dreams within dreams within dreams up to nth level. So guy takes a dream, that's level 1, then they take another dream inside that dream, that's level 2, and so on. So why am I showing that music to here right now? Because I'm doing the same thing with Git. Let me show you. Let me show you Git Inception. Okay, thankfully we'll be at the 2nd level. We won't make things much more complex. So we'll track Git with Git. So inside Git folder, I'll create a repo .git, and I'll create a repo git init dot, and let me do an initial commit. So, and let me also start a server. Let me start at port 4000. So I started a server. Let me open that as well. But I'm not interested in the contents. I'm only interested in what changes when I change something in the main working directory, what changes. So how will I do that? How will I do that? Do I have to commit in the working directory, then come back to Git folder and commit again? No, I won't do that. I will use this command, this autocommit. So if anything changes, head, refs, logs, config, it will do autocommit. Now let me start this. So right now there's only single commit, and let me go, sorry. And let me go back here. We have 4 commits here. Let me do something. Let me commit one more. And let me increase the font size. There's another tab. And let me commit something more. Not B, let me commit C. And I'm just changing alpha.txt, not alpha.txt. Okay, whatever. So let's see what happened here. Okay, that guy auto-committed. In fact, let's go what that did. Since it saw change in files, it did auto-commit. So let me go back here and let's see what changed inside here. So we have five commits right now. Inside that tree, I have new files. So, but what changed inside the .git folder? Let's see that. What exactly happened? So it has a lot of files actually. One thing changed is the commit edit message. That's the last commit message. So I changed the timestamp so that commit edit message is changed. Index, that is your working staging. So whenever you do a git add, it goes into staging, and from that staging, the commit tree is generated, the main tree. So we won't go much deep into this. It's a binary file. The format is pretty complex. So that's your staging. And Git also maintains a log of everything. So the head log is maintained. So head went from this one to this one, and it shows that it was through a commit. And that's how your Git log is shown. It also maintains a log for each of the branches. So right now we are at master branch, so it shows that. And we have 3 new Git objects. Now these objects are, once again, since we changed the file in the root directory, the commit object, the main tree object, and another file blob object. In fact, if you see, this is the commit object, BE, B is the commit object, and tree A43, and new blob. So A43 and new blob. So those are the 3 objects. But we have tracking, so let's do something more complex. How about if we create a new branch? Let me increase the font size. So I'll check out a new branch and also switch to it. And I just switched to a new branch. I didn't do any commit, so I should not, let me maximize this as well. So I did not do any commits, so this will remain constant, but my other things changed. Let's see what changed. So my head changed. My head points to a new file, and there's a new file. So that's your branch. Branch is just a file, nothing else. And that branch just points to a commit. So there you have it. That's your branch. And there's also log for this new branch, like the other logs. So Git stores a log for this branch as well. And it is also storing log for the head, and it just has the correct message. Check out moving from master to new branch. So let me check that out back. So let me commit something here. So I committed something, and let's go here. Now I have 6 commits, and I check out master. And sorry, I have 5 commits because I moved to master. Master had only 5 commits. My new branch has 6 commits. So what if I merge it? New branch. We'll see what happens. Now my master has 6 commits, and I have a new commit here. So let's see what happened here. The usual suspects, the ref heads master change because it's pointing to a new commit. And it's a fast forward merge, so there's no need to create a merge commit. And also there's one more file, which is a new file actually. This is orig head. So what is this file? This file contains any last commit before you make a dangerous change. So if I do a merge, if I do a git reset, it stores the last commit. What if I reset? What if I delete the last commit? So I'm right now at 6 commits. What if I delete the last commit? So this is the way to do it, but don't do it on your production code. So I reset a commit, and I'm back to 5 commits. And let's see what changed here. So my origin changed. In fact, it changed from some commit to other commit. One thing to interestingly notice is, if you'll notice this, it changed from BE to 0C, and this changed from 0C to BE. So your origin head changed exactly the opposite of your master. So just keeping the dangerous changes, and also you can see moving to head this, head tilde. So that's your dangerous change. And I still have 5 commits, so let me merge the origin head. You can refer to it, and you can merge it, or you can reset hard also. So I just merged it back. I'm back to 6 commits, and I am back to the original changes. So not to worry much about this. And so what do we do now? What about if our branches diverge? So right now it's a fast forward merge. What if I commit something in the master branch and commit something in the new branch, and then I try to merge because both have diverged? So let's see what happens then. Let me do echo d alpha.txt, and let me git checkout new branch, and let me change the num.txt. So both are at a different point right now. This has 7 commits, git checkout, master, and this also has 7 commits, but both commits are different actually. So this has changed to alpha.txt, that one has changed to num.txt. What if I now merge them? Git merge. So you can see 7 commits right now, git merge new branch. And it should ask you to put a merge comment. I just did that. So let's see now what happened. Okay, now we have 9 commits. So why is that? So one is the commit that came from the other branch. This is the main merge. It shows merge new branch. And I have commits which came from the new branch as well. In fact, you see right now, this parent, there are 2 parents right now. All our early commits, they only had 1 parent. So that was more like a linked list earlier. But right now it looks a little different. There are 2 parents. So what are these 2 parents? So these 2 parents are there because our branches diverged like this, and they merged back like this. So there should be a diamond sort of shape. This Sinatra app which I wrote doesn't show that right now, but I can show you that by graph git log. Yes. So okay, let me reduce it. So at this point, the branches diverged. My master had a new commit here, and my new branch had a new commit here, and I had merged them back here. So that's why you see this diamond sort of shape. So that's what. So that's with our merging. What about remotes? What are remotes actually? Like you won't always keep the code on your same machine. You will push to remote. So what are remotes? So first of all, you know that Git always keeps the complete history, complete commit history inside your Git folder. So there is no need for a central server. But remote are still required. Remote are required to keep your backups. So remote is a complete clone of your Git repository. It's the same folder as your working directory. So remote keeps your complete history. And also you require it for collaboration. So let's say there are 2 developers. One guy is developing something, other guy is developing something. So you need to push to a central repo so that you are not required simultaneously at the same time. Otherwise, one guy will be pushing to other guy's PCs. And that is not required. So that's why you push to remote, like GitHub or something, and you pull from there. So my changes went in, and my changes came back from the other guy. So let me show you remotes. How a remote is created and how it works. So let's keep track of this. We have 9 commits here, 13 commits here, but not worry about them. So let me create a Git remote. And you can create remote any way you want. Anywhere you have file system access to, you can create a remote. Whether it's your local system, whether over SSH, or whether over HTTP, HTTPS, Git protocol, lots of protocol there, but you just need the access to the file system. Once you have that, you can create a remote. So I'm just now creating on my own computer, on my own file system. I just created a inet remote, and let me add it as a remote. Git remote add origin and /. Okay, my repo origin.git. I hope I have the spelling correct. Okay. Now git push origin. So let's hold back without pushing. Let's see what changed here. We have 14 commits now from 13. And what is my remote? So when I added a remote, only this part changed. Only this part changed. So that is my remote. I just keep a configuration, nothing else. And remotes are very much like your local branches. So let me push some code there. Origin master. You can name your remote anything. I just named it origin. And by default, if you clone from somewhere, it's your remote is named origin. So there you go. I just pushed something there. And what went in? These are objects. It shows 28 objects. These are the Git objects which went there. So let me see what changed here again. Now if we are 15 commits. Okay, this looks exactly similar. This guy exactly looks similar to the branch log. And this guy exactly looks similar to a branch. And it contains a commit and it contains a log. Why this 0, 0? Because every branch starts from 0, 0. So that's what. Okay, and let me create another one. Let me create origin 2. Add, okay. Origin 2, okay. And I can push there also. Origin 2 master. Origin 2. In fact, if I put a use switch here, it does something. So let me show you. So let me refresh this. We have 16. There's another remote in here, origin 2. And if I put use switch, it will store a reference of this branch. So let's see what changed. So earlier was the remote config. It also stored a branch config. So what does this mean? It means that if I do a git push or git pull without any parameters, it will pull from the origin 2 master and will push to origin 2 master. So it's just keeping a track of that branch. So that's why a master is tracking that origin 2 master branch. So that's what is called tracking. In fact, you can see this. Branch master set up to track remote branch master from origin 2. And the configuration is stored here. And the other files are pretty similar. This is exactly same, this is exactly same. What else? What else can we do? Okay. Funny thing about remotes is that you can add the same directory as a remote. Let me show you how. Remote add loop dot. I just added the same folder as remote, and what will happen? Loop master, git pull loop master. Nothing happened. It's the same folder, so everything will be exactly same. It's like a dog chasing its own tail, so nothing will happen. But it's quite funny to see this. So these are our remotes. Let's see what happens. So how do you create a actual remote? Let's say you have a virtual machine or somewhere. Let's say you have a remote server. You want to create your repo there. Let's see how do you create that. So let me do SSH. This is my Ubuntu server running on my VMware locally. I just logged in. So let us create it like GitHub with a Git user. So let me do that. So I'm adding a user Git, giving it sudo options and all that. So let me do that. So I added a user Git. Let's go inside that Git guys folder. Let's go into his folder. Okay, okay. Oops. Now let me create a repository here also. Git init -bear. Why you use bear? Because you need bear repository to push. I'll show you why it is bear. My repo remote.git. And this bear does not have a working directory. So it's like exactly the .git folder without a working directory. So that's why it's called bear. You won't be able to push to somebody's working directory because it changes all his files. So that's why you need a bear repository. In fact, if you go in here, it's like a Git folder, except that there is no working directory. So let me exit once more. And let me try SSH once. Okay. So it's asking me for a password. Let me make it passwordless. I'll just make it passwordless. I'll copy the Ubuntu users SSH keys to the current directory. In fact, I'll put cp-r, and there we have it. Let me exit, and let's try. Oh, cool. We have passwordless access because I copied the SSH keys. So let me try to add this as remote. Git remote, add origin, git, not this one, that's my company. Okay, let's see the previous commands. This is the command. Git remote, add, let me name this remote as GitHub, and let me give this as a URL, my repo remote.git. Okay, I have it. So let me push to this guy as well. Git push GitHub master. There you go. It pushed to a remote guy. And you can actually, so let me do another commit. And you can actually do a multi-push. Origin to GitHub master. And this will, it'll push to all the repositories. That's quite cool. So if you have multiple, if you want to create multiple backups for your Git repository, that's the best way. So that's quite cool. And okay, sorry. Let me do one more thing. Let me go back here. Let me start a git server minus p 3000. Let me start a git server here as well. Minus d my repo remote.git. And let me go to Safari. So let me refresh this one first. This has 10 commits and 172.14. And this also has 10 commits exactly. So I have my own local GitHub sort of. What about read-only URLs? How will you do that? So let me go back here. Control Z, BG, make it background, and go inside my repo, git update. Okay, server info. So this will allow me to serve as a dumb HTTP repo. I'll show you what is happening here exactly. So let me go back. And if I click on this link on my Sinatra app, I can see it's serving the whole Git folder. Can you see it? Let me move it here. Okay, so you can see it's serving my whole Git folder. In fact, if I go back, let me move it. CD my not here. Git clone, and let me copy this exactly. This is your read-only URL. My clone. It cloned, and let's go into my clone. There you have it, your own local GitHub with a read-only URL if you want to share it with somebody. So that's all quite cool. So there we saw how the architecture of Git is, how simple the architecture is. The architecture is really simple, but the tool set around it is really awesome. You can create your own Git within a week or so, but the tool set, it's really impossible to replicate. We have a lack of time, otherwise I could have discussed more awesome Git commands. One of them is Git rebase to reorder your commits. Another one is that when you do a merge, you can specify merge strategies, like how to merge and what strategy to use. Default is recursive strategy. There are other strategies as well, so we cannot go into that. And one of the most obscure Git commands, Git bisect. Now what that does, it does a binary search on a commit to find an untested bug. So if you read more about it, you will find it. So that's more about my session. How do you get all this? What I got? Let me show you. Git Guts. Let me make it smaller. GitHub, at my GitHub account. And let me show you my favorite command. Let me clear it. This is my favorite command. Git. That's my favorite command. I really love this. Thank you. Thank you.
Hi. Sorry, this could be off topic, but what did you do with your terminal?
What did
It's
I do?
amazing.
I couldn't hear you correctly.
What did you do with your terminal? Like
My terminal, okay. So my terminal is item plus oh my ZSH and some themes. So that's why it looks really cool. It shows me my folder, and it also shows the current branch, and it also shows whether it's a Git folder. And if I change something, it shows that something has changed with this color. It went from green to orange. So you can try it out, just search for oh my ZSH and you can find it out. Any other question?
So Shadab, nice talk.
Thank you.
Yeah, so Shadab, basically I would like to know what is the difference between Git rebase and Git pull?
Git rebase and Git pull.
Yep.
So pull is when you pull from origin, pull from any remote. From your tracking branch, it merges your change. It fetches first all the commits in that branch and merges. Git rebase is used locally to rebase your, so rebase means reorder your commits. So like if you had 10 commits and you mentioned the wrong issue number, mentioned the wrong issue tracker, and if you want to change it, you can do a rebase. So that's what rebase is used for. In fact, you can do a git pull minus rebase. What that will do, it will replay the commits. So instead of having a merge commit, it will replay all the commits. So you can do a git pull minus rebase, but don't do a git rebase if you have pushed the code, because your commit IDs will change and somebody else will, if he gets it, it will be all conflicts. Because the same file has changed in different commits, so he'll get conflicts. So never ever push, never ever do hard reset unless you are absolutely required. What I showed to you is very dangerous.
Hi, thanks
Hi.
for a nice speech.
Thank you.
Actually, there is no such command called git music or fireworks, which you just wrote in your terminal.
I didn't
So,
get it.
Git music
Git
or
music.
git fireworks, whatever you have written just few minutes ago.
So I can show you how that happens actually.
Is
So-
it a bash script or whatever? Did you do?
So how did I play the Git music? That's what you're asking?
Yes, also that fireworks thing. So whatever you
Okay,
did.
okay, all right. So Git is very cool in the sense that if you name any file git hyphen music, so what Git will do, if you specify git space music, it will run that command. I don't have a sound right now, but it does the same thing. In fact, I can do this also. So if you have in your path a shell file or a script, git hyphen something, Git will play it like git space something, and it will appear as git subcommand. So that's why Git is quite cool. In fact, if you want to see how much time we have, I think we are over. Let me show you the source code. I hope the net is working. Okay. So notice the lack of spec folder. That's creativity. And let me go show you this bin folder. So that has all my scripts. You know if I go into Git music, it's a bash script actually, and it uses afplay command. And Git Autocommit, it uses a guard, it is Thor. So most of my code uses Thor as command line framework. So that's it. Any more? Okay.
Yeah.
Okay.
If I'm working on a particular feature which takes a lot of time, let's say 3 months, so what's the best strategy to follow so that I don't get out of sync with the main branch?
Okay. So first of all, you should create a different branch for a project, and you can always merge master in your code. So you keep merging the master in your code so that you're not very much behind the master also. So instead of merging your code in the master, just pull master into your
So
code.
finally, when I merge my branch, like feature branch into the main branch, that won't
Cause any conflicts because Git will detect which commits are automatically merged in your code. It won't remerge those code. So it will only merge the latest changes.
And what's the right use case to use a rebase again? Instead
Never
of
do
a
the
merge.
rebase. So that's my suggestion. But if you want to do rebase, only do it when it's really urgent and not on the code that has been pushed. So if you do git push and somebody else pulls it, and when you're doing a rebase, you're basically changing all those previous commits. And when that guy does a git pull, he'll get a really bad error. Conflicts, lots of conflicts actually.
All right, thank you very much.
Thank you.